Analytic Process Control System Station. My name is Roger Langat, the team leader, and the team members are Isaiah Nasimo, Jafet Tao, Joe Kasaine, and Mogambi Max. So basically, the analytic process control system consists of several components. To start with, we have the control system panel, which has got a PID controller in it. Then, as you can see, we have three different tanks in this, and the first tank here is called the pH reducer, which contains a low pH solution. Then we have the riser tank, which has got the high pH solution, and then we have the mixing tank here. Then we've got as well the inductor pump, which pumps the lower pH solution into the mixing tank. We have the metering pump, which pumps the higher pH solution into the mixing tank. Then we have the agitator motor, which mixes the two solutions in the tank to control the pH. Then in this panel as well, we've got three different types of sensors. To start with, we have the Honeywell pH sensor, which monitors the pH of the solution, and then we have the pressure sensor, which checks on the level of the solution in the mixing tank. Then we have the flow sensor in here, which regulates the flow or controls the flow rate in the system. Then we've got within this mixing tank, we have two limit switches. The upper limit switch here and the lower limit switch. The upper limit switch controls the input solenoid, and the lower limit switch controls the output solenoid. So basically, the function of this analytic process control system is to control the pH of the solution by using a PID controller to maintain a desired pH level of the two solutions by mixing the lower pH solution and the higher pH solution together. So this team, we had a task to do in this analytic process control station, and I'll introduce my member Maximilian Mwenda to take us through the task.
Thank you, Rogers. Again, I'm Maximilian Mwenda, and I'll take you through the task we were working on as a team. We are simply replacing the conventional PID controller pre-installed in this machine with the PID controller functionality available in this PLC, a 71200 training kit, which we are also incorporating an HMI panel for monitoring all the process and functionalities, and also for user friendliness. In this panel, we can monitor all the functions of the machine, and just to take you through the user friendliness of this machine, as you can see, there are the start buttons and the stop buttons, and I can start the machine, and then I can monitor the pH and water level. There are two indicator tanks in this. The one is just indicates the pH level on the mixing tank, and the other one indicates the water level, and that's it. I can stop the machine. All these processes are just achieved with a well-written program, which I'll forward my next colleague to expound on that. Joe, please.
Thank you. And as per my teammate has said, I am taking you through the program. Basically, in our program, we have 2 cyclic interrupts, 4 functional blocks, and one main organization block. For the cyclic interrupt, basically, what we do in the cyclic interrupt is collect the readings for the Honeywell pH sensor and the pressure sensor with the PID to get desirable output to control both the flow control valve, and the metering pump, as you can see in the program, for the water PID and for the pH PID. Then I'll go to the main function block. The main function block basically is composed of the whole cluster of our program. It contains both the function blocks and also the other incorporates actuators such as agitator motor, circulation pump, alarm, and a couple of tags. For the functional blocks, they are both for the input and output for the pH and the water level. And basically what we do in the function block is to scale or normalize the values you get for the pH sensor and the pressure sensor at certain ranges, such as for the analytic signal at 420, to get basic outputs that are used in the program. Then, as you can see in our program, our first input is a start, which is a memory bit for the HMI, followed by the 4 function block which I've explained earlier. Then we're followed by a tag input until the function of this tag memory bit is to keep the program in a continuous loop. We have certain conditions, certain operators that are used to run the agitator motor. Like for agitator motor, for it to run, the value for the pH has to be lower than 6.5 and greater than 7.5. as seen in our program here, the circulation pump always run continuously to make sure that the fluid in our tank is constantly running through the system. For alarm, we have set some kind of conditions here, only that the alarm will turn on when the pH is less than 2.0 and greater than 12. For the tag 1 here, it's used basically to incorporate another program for the PLC, basically for controlling the metering pump. And that's it. I want to introduce my colleague here, Isaiah Nasima, to take us to the connections.
Yes, for us to be able to achieve this functionality, we must connect the PLC to the system itself. And we did this by connecting some different wires, as you can see. Now in these connections, we have the PLC controlling 5 main outputs, and we have the PLC monitoring 2 main inputs. Now the 2 main inputs that we are monitoring are the analytic pH signal, which we get from the Honeywell pH sensor, and the level sensor, which we get from the pressure sensor. Now, for us to be able to do this, we have to supply 24 volts to each of the sensors. As you can see, there is an input for 24 volts here at the level as this level sensor, and another input for 24 volts at the analytic signal. After supplying the sensors with 24 volts, we get an output that is current, an output current that is between 4 to 20 milliamps, as you can see, as shown there. Having gotten the 4 to 20 milliamps current, we pass it through a 250 ohm resistor and take it to our analog inputs in the PLCs. Our PLCs, however, they only read voltages. So the reason why we have taken it through the 250 ohm resistor is so that we can be able to use the ohm principle. We can be able to use the ohm principle to be able to calculate the current that we are getting in here. And through the program, we have been able to do that and achieve the exact pH and the exact water level that we desire. Having done that, we output, again, as I told you, we have outputs that we are controlling. We are controlling the flow valve and we are controlling the metering pump as analog outputs. Those are the 2 analog outputs that we have. We are controlling the flow valve, having known the water level, and we are controlling the metering pump, having known the pH of the liquid that is inside the tank. Now the other 3 outputs that we have, one is to control the circulation pump. The first output will control the circulation pump, the second output will control the agitator motor, and the third output will control the alarm, which turns on when there is a warning, as explained by our friend Joe. To be able to do this, we used a user-friendly interface, the HMI, which the whole process will be explained by our friend Japheth.
Okay, I will talk, and I'm going to take you through the whole process. As you can come and monitor in the pH, it is a base of 10. In our set conditions, it is that when the pH is greater than 7.5, and the motor is going to start. And right now we're going to start the whole process. As you can see, the pH is reducing through the induction pump that's going to pump the acid. Until now, as per the set conditions of 7.5, and you'll check that the motor is going to stop at some point. It has stopped due to the set conditions of 7.5. And as the pH reduces, as you can well see in the HMI, it now reaches at neutral pH. Okay. After some point, when this other set condition has been reached of 6.5, and the agitator motor is going to turn on. When now the acidic is below 6.5. And just give it a minute. After this set point is almost reached. As you can see, the agitator motor turned on. And basically, and that's how we were able to achieve the whole project. And then for the alarm, and you can see that when you remove, the alarm is going to turn on. And you can see that the alarm is turned on since there is a Bluetooth connection between the PH sensor and the PLC.